Well, welcome to Creative Escapes, Understanding the Brain. My name is Andrew Clark. I'm Associate Director for the Center for Research on Teaching and Learning Excellence, and we're glad that you've joined us today for this session. Our the director of the center, Dr. Ann Cavallo, is on vacation this week, but sends her greetings. And so we have two distinguished presenters who are going to be speaking to us today, and Dr. Dan Levine from the Department of Psychology from the College of Science, and Dr. Dan Robinson from the College of Education. And so without any further ado, let me turn it over to Dr. Dan Levine for his talk to us today.
All right, can you see the screen now? Can you see my, oh, wait a sec.
Not just yet.
Oh, all right, so maybe
I need to go
to the sharing mode.
There you go.
All right.
Just put it in presenter mode and we'll be ready to go.
All right. Talking about emotion, reason, decision making in the brain. I'm going to introduce a lot of different people's work about how all these things interact. And then toward the end, I'll talk a little bit about my work, both some computational modeling I've done, as well as a book that I've written on this. Now, in popular parlance, we think of emotion and reason very often as opposites. We say, if you're not acting rationally, you're acting emotionally, or if you're not acting emotionally, you're acting rationally. The truth is a lot more nuanced than that. Emotion is as much often a partner to reason as it is an adversary to reason. Emotion helps with reason decision-making in some cases and hinders it in other cases. Plus, there's a lot of decisions we make that are, in a sense, neither emotional nor rational, but just automatic. That we don't think or feel very much, but we just act. All right. Yet, the work of Tversky and Kahneman, starting in the late 60s and going through the 1970s and 80s, and Kahneman ultimately won the Nobel Prize in Economics, and Tversky would have shared it except he had passed away by then, showed that human decisions in some characteristic ways do not follow rational logical norms of self-consistency or maximum utility, as it's called in economics. And there's a lot of different things that they did and different patterns of decision-making that came up with. And in the short period of time, I'm not going to review all that, but I'll just give one example of theirs. 600 people are expected to die due to an epidemic. They said a rare Asian disease, and this was back in the 70s. So in a certain sense, they were amazingly prophetic. And subjects have to decide between two public health programs. Not to make the slide too busy, I didn't list all the alternatives, but basically they have to decide between saving 200 people for sure, or saving 600 with probability a third, with saving nobody with probability 2/3. And they preferred the certain saving of 200. All right, then there were other subjects who were asked, did they prefer a program where 400 would die, or 600 would die with probability 2/3, but none would die with probability 1/3. And they preferred taking the risk that more would die so that there was some possibility that none would. And this is logically, this is across subjects, but it's fairly robust and it's logically inconsistent. The reason being that 400 dying is the same as saving 200. 600 dying is the same as saving none, and nobody dying is the same as saving all of them. The only difference is they're framed in terms of people being saved or people dying. All right, now, okay, this is cut off at the very top. I don't know how to deal with that. Presenting, give control, stop presenting is covering up something. Okay. Does this mean that humans are hopelessly driven by blind emotion? And the answer is no. Emotion, reason, and instinct interact in the brain in complex ways, and all three are needed. William James was one of the founders of the discipline of psychology as we know it, divided the mind into instincts, emotions, and thoughts, with a lot of interactions between them. Paul MacLean, a behavioral neuroscientist who was informally one of my mentors during my graduate school period, divided the brain into different layers, the human brain into different layers that arrived at different stages of evolution. And it's roughly, very roughly, stood up the test of time. We've got this reptilian brain responsible for automatic instinctive behavior, the old mammalian, paleo-mammalian brain in the middle, responsive for emotions like love and fear, although reptiles do show a certain amount of fear. And then the neo-mammalian brain, or the thinking cap, the outer layer or cerebral cortex. All right, and neuroscience shows that emotion and cognition are tightly connected. We start talking about brain areas involved in emotion. The hypothalamus at the base of the brain, close to the endocrine glands, ties the brain to the heart, the digestive system, and the endocrine system, and the skin, the viscera in general. Then you've got the amygdala, which is these two red areas right here, and that processes the emotional importance of stimuli or potential actions. And through the amygdala connects to the hypothalamus, which in turn connects to other organs of the body. But also, as we'll see, the hypothalamus and the amygdala have some connections up in the cortex. And here are various other areas involved in emotion. Amygdala processes possible threat or reward. Striatum, which is part of the reptilian brain, does a lot of the automatic behaviors. Insula, which is just underneath the cortex, it's kind of the older part of the cortex, processes subjective emotion. And here you've got the ventral, medial, and orbital parts of the prefrontal cortex, which are kind of the connection to the amygdala, of the amygdala and hypothalamus, to the rest of the cortex, which is out here. So they connect the emotional to the cognitive area. And there's all kinds of interesting consequences when those areas are damaged. All right. Antonio Damasio wrote a book called Descartes' Error, in which he debunked the idea of emotion and reason as enemies. He showed that patients with damage to this area make bad decisions due to a lack of emotional connections to their thoughts. And that the bad decisions could go in two possible directions. They might be impulsive. Phineas Gage was a famous patient in the 19th century who was a railroad foreman in Vermont, a very sober, responsible citizen, until he had a railroad accident with dynamite in which a rod went through part of his forehead. And Damasio's reconstruction found, based on his clinical reports, found it was this general area of the frontal lobes was what was most damaged. And he turned from this very sober guy to somebody who couldn't hold down a job or a marriage, and tended to use profanity in public, and otherwise just was very impulsive and couldn't control his decisions. Or Damasio had a patient damaged in the same area who would over deliberate on minor decisions, like obsess endlessly as to which of several restaurants to eat at, and even drive to the restaurant to see if it would help him make up his mind. It didn't help him make up his mind. And this is not a loss of cognitive functions or intelligence. These people's IQs and cognitive tests were normal. All right, and the other thing is emotional and automatic or instinctive kind of get lumped together in our popular parlance. They're not the same thing at all. You've got these three layers of the triune brain, and the reptiles have, well, they probably experience fear because they have the kind of fight or flight reactions, but it's likely that they don't experience some of the more complex emotions, such as emotions involved with bonding and parental and sometimes mate bonding, of which mammals do. And that's true in large part of the development of this limbic system, which includes the amygdala and a few other areas. Now, Pessoa and his colleagues showed that the amygdala is not automatic pilot, as we like to think of it, but is subject to attentional control. And I'll review the details of their study. fMRI is this technique for looking at brain activity while people are performing a task. And they looked at subjects looking at faces that were either fearful, happy, or emotionally neutral. And there were pairs of colored oriented bars, like the bars could be sometimes, they'd have two of them that were horizontal, or two that were vertical, or one that was vertical and one that was slanted, or one vertical, one horizontal, above the face. And sometimes the subjects were asked if this face were male or female. So that cued them to attend to the face. And other times cued to attend to the bars, asking, are these the same or different orientations? Like if they're both horizontal, they're the same. If one horizontal and one vertical, they're different. The results were, he was looking at activation in the amygdala. And he found that the amygdala responded more to emotional than to neutral faces, as would be expected. But what was a little surprising was that the amygdala activation was larger when they were attending to the face than where they were attending to something else. So this area involved in emotional reaction is subject to attentional control. And there's a lot of other studies which show this. Another study would show that emotional and automatic aren't synonyms is a work of Berridge and Robinson. And they studied drug addiction in rats and concluded from a lot of their studies that drug addiction involves a drug capturing the dopamine system, dopamine being one of the neurotransmitters in the brain. If anybody knows somebody with Parkinson's disease, that involves a dopamine deficit in a particular area that's treated by dopaminergic drugs. And Berridge and Robinson found that this was rats that were dopamine deprived through chemical antagonists of dopamine lost motivation directed toward a behavior, but it didn't affect liking or pleasure. They used drugs sometimes, but they used sweet tasting foods at other times. And they found that motivation directed toward doing something and the pleasure associated with it are somewhat separate systems in the brain, although related and interacting. And that makes sense because humans will crave a drug even when they no longer take pleasure from it. And we do a lot of things that we don't particularly enjoy but feel compelled to do. So automatic craving is not the same as emotional enjoyment. All right, now I'm going to switch gears and talk about some work I did on emotionally involved decision making at the level of a computational model. Rottenstrike and Rottenstrike had worked with Tversky, who I mentioned before. They asked some subjects, give a hypothetical choice between getting $50 or the kiss of their favorite movie star. The majority preferred the money. But then he asked them, give a hypothetical choice between a 1% probability of obtaining the money and a 1% probability of obtaining the kiss. The majority preferred the kiss. Now, why should that be? Well, when we have a low but non-zero probability of something will happen that we either want to happen or dread happening, we amplify the probability in our minds. Psychologically, we're not linear in terms of probability, so that a very tiny percentage probability of winning the lottery, many of us amplify, we act psychologically as though it's much more likely. And similarly, we buy insurance against very low probability disasters, effectively amplifying the probability of something negative. Now, what Rottenstrike and she said is that the amplification is greater for the kiss than it is for the money, because the kiss is tied to a personal relationship and therefore more emotionally charged. All right. Now, I believed that explanation and simulated this data in a brain-based neural network. I don't have time here, but somebody could ask me how these work. You've got a system of equations describing the activity of nodes in a network that could either represent brain regions or could represent cognitive entities like potential actions or stimuli. And the components of the network included the posterior cortex, parietal and other areas of association cortex that encoded these probabilistic options like 1% probability of kiss or 100% probability of kiss or 99% of money. Then the amygdala, which had encoded emotional evaluations of the different attributes like the possibility and the probability. The orbital frontal cortex, which emotionally evaluated categories of options. Another kind of cognitive emotional area called the anterior cingulate encoded response planning. The basal ganglia, including the striatum, part of the reptilian area, accepting or rejecting possible actions. And then your premotor cortex, something leading into the motor cortex for actual execution of the response. And these node activities simulated a decision, deciding between two options. One of the options leads to a greater activation of this execution area than the other, and you decide based on which one is larger. Again, I don't have time to explain all the computation behind that. And also, I want to mention a book that just came out. All right, from current slide, yeah. And you can order it either directly from the publisher or via Kindle from Amazon, which is a little less expensive. The publisher, this is a book that I wrote for a general educated audience, although it has to be a non-science phobic part of the general educated audience. And it includes the societal implications. I talk in there about the harm to society from regarding emotion and reason as opposites. Show belief that you can't both think and feel at the same time. You can't be smart and kind at the same time. Has all sorts of negative social implications. I talk about movements in history, and I advocate healing the split using the knowledge that comes from science. And I hope I've done that a little bit in this talk. Thank you very much.
Dan, thank you very much. Really appreciate it. Let's turn it over now to our next presenter, Dr. Dan Robinson from the College of Education, who I really appreciate joining us from his vacation and taking a few minutes to speak to us. So Dan, thank you very much, and it's great to see you, and I'll turn it over to you.
Great, thank you very much. I just wanted to ask if everybody's able to see my slides. Andrew, are we able to see?
Yes, I can see it. If you could just put it on presenter mode, that would be great. There you go. Okay. There we go. Well, thank you, Andrew, and thank you everybody for attending on a summer day. My appearance is this because I just got off the golf course. I'm in Yankton, South Dakota. So thanks for allowing me to do this in a rather casual format today. So my brief talk, like Dr. Levine's, I'm going to just talk about something unique to the brain, and I'm going to try to use the analogy today that effective learning is a lot like effective eating. There's a right way to do it, and I hope to leave you with a couple of helpful tips today. I'm not going to be able to go in and explain exactly how the brain works in detail, but hopefully we'll walk away with some useful information today. So I'd like to use the analogy of dieting versus learning. And over the last 5 or so years or whatever, there is one approach to sort of regulating, maintaining a healthy weight in terms of, especially for people like me who are over 50 years old. We're always interested in, what can we do to, not put on too much weight, not reach an unhealthy stage, things like that. So I'll start with dieting here, and generally the word of thumb, the rule of thumb is it's not so much what you eat, it's how and when you eat. And if you think about that's a little bit strange because are we able to eat chocolate pie? Can we eat a lot of fatty foods, a lot of carbohydrates, stuff like that? Well, you don't just have a blank check to eat whatever you want. But it's not so much what you eat, it's paying attention to specifically how and when you eat your food. And then the analogy for learning that I'm going to try to draw on today, it's not particularly what you study, it's more how and when you study. So, we all study information, we all try to take good notes, we all try to have good resources, find good material on the web, things like that. But in terms of learning and remembering information long term, which is what a lot of students want to do, to remember something for a test and so on, it's more the how and when. And so that's what I'm going to try to draw on today. So going back to eating, and this is borrowed, stolen from the approach to eating where you sort of do intermittent fasting and things like that. So did you eat at a level 3, meaning that there's 4 levels of hunger? You're not supposed to wait until you're absolutely ravenous to eat. But you're also not supposed to eat where you're, hardly hungry at all, where you're simply bored. So a lot of people who struggle with weight simply eat for something to do. So you should wait until you're like at a level 3, wait till you're pretty hungry to eat. Did you take 10, 5, 10 to eat when you eat a normal meal? You're supposed to eat for 10 minutes and then put the fork down, wait for 5 minutes,
and then come back and maybe eat for another 10 minutes. This allows your body to actually kind of catch up, and your brain to actually register that you've eaten food, because sometimes you can reach those satisfaction levels without eating as much if you sort of take a break in between. Do you chew slowly? Again, you know, one of the problems with people who put on too much weight is that they sort of just inhale their food and they don't really enjoy it. So chew your food slowly, enjoy it, and you slow things down. Sometimes you can become full with less food. Do you put your fork down between bites is another way to sort of slow things down. So you can see here that this has very little to do with what you're eating, what you're taking in, and more about the style of what you're eating and how and when you eat. Do you wait until 9 a.m. and to have a snack in the morning, and do you eat no later than 7 p.m. at night? And again, that's sort of the fasting over the evening. Try to wait until lunch to have something. If you need to, have a real brief snack or something like that. And then for learning, really it comes down to a couple of questions I want to focus on today. And there's lots of things we could talk about with effective learning, but given a short time period, let's focus on just a couple. Are you retrieving rather than studying? And for most of us, that means, are you quizzing yourself when you're trying to remember information, trying to learn information long term, rather than simply studying? And studying for most of us simply means, and it's terrible, it's a terrible process. If you ask most students, you know, if they're going to study tonight, what are they going to do? They're going to skim through their textbook, they're going to skim through their notes, they're going to look at their notes over and over again. That's sort of repeated presentations of information. And that tends to be relatively less effective than attempting to retrieve information from memory. So attempting to sort of test yourself, quiz yourself as a study process is much more effective than simply having the information presented to you over and over again. And then the other one, do you wait long enough between retrievals? And when you're testing yourself, you need to think about spacing out your study to the point where, you know, you're not cramming all at once, but you're spacing things out. And you want to wait long enough, and this is going to sound really ridiculous, but it's supported by research. You want to sort of let yourself forget information. In other words, here's the sentence that's going to sound crazy. One of the best ways to learn information is to allow yourself to forget that information. And I'll try to explain more of that as we go on. Okay, so trying to move on here. Let's see, maybe I'm stuck. Here we go. Okay, so like Dr. Levine, I'm borrowing heavily from other people's you know, seminal work here, and this was from Robert and Elizabeth Bjork 20 years ago. Just a few things about the human memory system. It has a remarkable capacity for storing information. So, you know, again, the problem with memory isn't so much are we able to get information in. Some researchers, you know, hypothesize, theorize that we almost store everything that we ever sense. Everything we ever sense is stored in our brains. The problem, though, is getting it back out. So we have a highly fallible retrieval process. We have trouble getting information out of memory. It's not so much having trouble getting information into memory. What is accessible in memory is heavily dependent on the current environmental, interpersonal, emotional, and body state cues. So whether we can recall something at any given point is heavily dependent on what state of mind we're in, what environment we're in, and so on. Retrieving information from memory is a dynamic process that alters the subsequent state of the system. They call our retrieval systems messy systems in the sense that whenever we go in and get something out, we've forever changed how that information is stored in memory. And then here's the one that's important. Conditions that produce forgetting rather than undoing learning create opportunities for additional learning. So yeah, if you walk away today and talk to somebody this weekend and say, I listened to some crazy guy at UTA and he was talking about one of the best ways to learn is to forget. Sounds kind of silly, but it's actually effective. Okay, so do we study or do we quiz ourselves, right? We have lecture notes and a textbook to study for tomorrow's test. We can choose to spend our available study time either looking at the materials over and over again, which is the #1 learning strategy by both high school students and college students. They look at materials over and over again, or we can quiz ourselves. And this is something that people have termed retrieval practice because they don't like to use the term test because testing in education has a very negative reputation these days. But honestly, the best way to study involves trying to retrieve information from memory and see if we can pull that out. And then that information becomes much stronger once we've attempted to retrieve it and successfully retrieved it, as opposed to just simply blindly looking at stuff over and over again. It's sort of a levels of processing analogy in the sense that simply looking at materials is a very superficial, very shallow level of processing, whereas quizzing ourselves, retrieving information is a deeper level of processing. So again, I've given it away. Quizzing ourselves tends to be best, and there's a ton of research on what's called the testing effect in cognitive psychology, which shows that that's much better than simply studying. And then massed or distributed practice. Massed practice is studying all at one shot, and that's usually what students have to do if they haven't gone to class all year, haven't read the book, and tomorrow's the final exam. That's a cram session, and of course, you know, if a student asks me, well, what do you suggest I do? The test is tomorrow. Well, you better start cramming because there's no way to distribute your practice with one day to go. But however, if you have an opportunity, you should try to distribute or space out your practice. So let's say we have 3 hours this week to study for Friday's upcoming test. Right? And plan A, we're going to study simply 3 hours, 7 to 10 p.m. Thursday night. That's the night for the test. Information will be fresh in our memory. That should be pretty good. Plan B would be to study 9 to 10 p.m. Monday night, Wednesday night, Thursday nights, same 3 hours of studying, but we space it apart. And what we see with repeated research on the spacing effect, or what's called distributed practice, is that for the short term, if you test people immediately, cramming tends to do better than spacing things out if you want to test people immediately after they've studied. However, if you're interested in knowing and remembering information more than just an immediate test, let's say you'd like to remember it 2 weeks from now or a month from now, the spaced out sessions are much more effective for long-term learning. And that's one of the dilemmas in cognitive psychology, is that students, I think a lot like eating, when you eat, you want to reach that level of satiation. You want that full, satisfied feeling that I was hungry, I feel good now, and you like that level of emotion. And with studying, we do the same thing. We like to try to, you know, look at things over and over again, feel like I feel like I know this pretty good. You know, I've glanced at it over and over. I feel I know it pretty good. If we were to quiz ourselves, then we discover just how much we don't know that information. And if we can quiz ourselves, get corrective feedback, quiz, get corrective feedback, and so on, that's going to be much better in terms of knowing things in the long term. But it might not give you that immediate level of satiation or satisfaction that you would get similar to the feeling after you've eaten a nice full meal. So as students, you have to learn to recognize that for long-term learning, you may be doing things that don't feel as comfortable, but they're going to be better for you in the long term. So a basic problem we confront in designing instruction or in managing our own learning is that conditions of instruction that make performance improve rapidly and prevent forgetting during the acquisition process often fail to support long-term retention and transfer. So I'm talking mainly about, you know, looking at things over and over again, sort of cramming. Those all give students a false sense of, I feel like I know the information, so on. Those same students often come to me and other faculty after the first test or quiz in a class. I thought like I knew this stuff. I studied over and over again. I didn't do very well on the test. What's going on here? And again, that's that false sense of security that they might have felt like they knew it right then and there. And if I'd have quizzed them, you know, like on Thursday night at 10 p.m., they might have done pretty well immediately. But when we wait till Friday afternoon, the test, their memory was not as strong as if they would have spaced out their study. Whereas conditions of instruction that appear to create optimize long-term retention and transfer. So again, we talk about here something called desirable difficulties. And the desirable difficulties we're talking about here today is using tests rather than presentations as learning events. When you study, you should try to, you know, use flashcards, something like that, where you're actually testing yourself. It's okay if you don't know it right from the start. Just make sure you have that corrective feedback on the back of the card. And then do that over and over again. Make yourself retrieve the information. Make yourself answer questions, because that's a much more active study process than simply sort of lazily looking information over and over again. And then distribute or space out your testing sessions. And how long should we space out our testing sessions? Well, the answer is you want to wait just long enough to where it's difficult, but you can still successfully retrieve the information. So if you're studying math or something like that, that may mean waiting a couple of hours. It may mean waiting a day or so. But you will be able to figure that out over time, how much time you need to space out between your testing sessions so that you end up with the best long-term learning. So the word desirable here is important. Remember, not all difficulties are desirable. There are many undesirable difficulties during learning, so we don't want those. You know, some examples of undesirable learning are just making information incredibly hard, having a lot of interference, having instruction that has a lot of distractions. Those are undesirable difficulties. But desirable difficulties are desirable because responding to them successfully engages processes that support learning, comprehension, and remembering. So, digging in, trying to get deeply involved in the information, that's a desirable difficulty. Okay, and that's it. How did I do on time? I guess I did okay. And there we go. Andrew, back to you.
Thank you very much. Well, I appreciate both of you for your insight and for your presentation, and would like to open it up for questions. We've got a good amount of time, so if there are questions, feel free. Let me just bring up my little question slide here that was created so that we can at least use it. But if you've got questions, please feel free to put them in the chat, things that you would like to know or observations that you have for our presenters, and Dan and Dan, you can feel free to interact with each other too if there's something that you wanted to build on based on what the other has said. Feel free to do that too. Let me see here. So I have so there is one question here, and that is, how does forgetting help with learning? So I think, is that maybe for Dan Robinson?
Sorry,
Sorry.
I have one of those computers where if something else pops up, it blocks me, and I was trying to unmute. Could you repeat the question, Andrew? I'm sorry.
Yeah. How does forgetting help with learning?
Yeah. Well, let me use the analogy of going and working out or training for a marathon or something like that. We all know that, if I want to train to bench press 300 pounds, or if I want to learn to run a marathon, and right now I can't run, 3 or 4 blocks, that I need to go out and practice running. I need to, or practice lifting weights or whatever. But the one thing I can't do is I can't go out and run 20 miles a day if I'm training for a marathon, especially if I'm a guy my age in my 50s. Or I can't go out and I can't lift weights every single day because we need time for our muscles to heal up. Once we break them down, we need them to be able to heal up, repair, get stronger. So we need to sort of space out our workouts. Well, memory muscle, so to speak, is sort of similar to that somewhat. And by forgetting, it's similar to working out in the sense that we're sort of breaking them down, we're making them weaker. And by having some space then between times, we're allowing that breakdown to occur. And when we start retrieving again, then we get feedback, we successfully retrieve, it allows them to make them stronger again. So that's a good analogy that I can think of in terms of how forgetting benefits learning.
Great.
Good question.
Dan Levine, anything you want to add?
Yeah, I would tend to agree with that.
Great. More questions if there's any. Dan, can you Levine, can you talk a little bit about your book? What was the impetus for writing the book, and what do you hope to achieve through it? What would make you feel good if in terms of achievement for the book?
Okay. Well, I went into this field in the first place in order to understand things that were happening in society. I started out, as I mentioned to you earlier, as a graduate student in mathematics. After my first year of graduate study, this was during the Vietnam War. And mine was the first class not to have automatic student deferments as grad student. And so I went and worked for 2 years at the National Institutes of Health, and people wanted me to somehow apply math to biology at that point. And also, kind of synchronously, I wanted to understand the psychology behind policies such as the war and such as racial injustice, and why policymakers were doing the things they were doing and why people were going along with it. So the best connection I could make was via neuroscience to psychology. And there weren't very many people doing mathematical modeling relating to neuroscience or psychology. In fact, neuroscience and psychology were not together. Neuroscientists and psychologists were not talking to each other as much as they are now, which is quite a lot. But I found somebody to work with, and that led to the kind of mathematical modeling I was doing. So I always wanted to say, what does this tell me about society? What does this tell me about how we should organize both institutions and social customs to bring out what most of us believe to be the best in people? And in the book, I can trace a lot of that has motivated a book that I wrote before this, which eventually UTA published as UTA Library published as an ebook. But I could trace a lot of unpleasant things to this disconnection we have between our rational selves and our emotional and instinctive selves. And the disconnection that is aggravated by technology and getting us away from our roots and away from what's meaningful. And I don't advocate going back to a pre-technological society, but I advocate reconnecting us to our roots, our communal roots, our collectivist as well as our individualistic roots. And reconnection within the individual brain fosters reconnection across society. So I hope that isn't too long of an answer.
So we have another question in the chat there. It says, I'm curious, when in our society did being kind coincide with not being smart? Was it a specific time period?
The being kind, well, I think in a lot of our popular folk psychology, we regard people who are smart as elite, somebody you don't want to drink a beer with. We've seen several presidential elections in which a candidate seemed to be, a good policy wonk who understands the issues, but the other candidate who wasn't so strong on policies, in fact, even disagreed more with the voters on policies, was seen as more of a kind of down-to-earth person you could interact with. So we detach them. We sometimes regard people who are kind as bleeding hearts who are not really thinking things through. And we regard people who think things through as, cynical and either elitist or cynical and not terribly nice. I mean, a lot of these things are just unconscious trends in our society, of course, that not everybody has, not all the time. but they are prevalent quite a bit. So I do think that we have a bias. We have some both anti-intellectual and anti-emotional biases at different times, and we need to. The book advocates a reconnection.
Interesting. Dan Robinson, so you're talking about how people learn, and I mean, to what extent is that sort of related to the way that maybe we as faculty assess learning? In other words, have we kind of almost forced people to try and learn a certain way because we've the exams that we put together? So we traditionally, it's like you have a midterm and you have a final, and students have to cram for that. And so instead of looking for maybe other ways of assessing, to what extent has sort of one influenced the other?
Well, there is research on how much students remember from a course long term, maybe a semester after the course is ended, and you'll find, not surprisingly, that instructors who only give one final exam compared to instructors who might have, a quiz or test every 2 weeks or something like that, the students tend to learn more a semester after the class. So sometimes instructors can sort of space out instruction and allow students to do that. Also, giving a comprehensive final exam at the end requires students to have to try to remember all the information in the entire semester-long class, which is good. Whereas if you don't do that, that sort of signals to students that the stuff you learn the first month, that it's not really important, and we won't be bringing that up ever again. So there are ways to do that. And then, like you said, students can fall into the habit of putting things off to the last minute, but instructors again can try to structure their classes right. And right now there's really good hope for interventions that can help students who need the discipline of when to study and how to study. You can send text messages to students on their smartphones now and say, hey, you've got a test coming up next week. How about responding to these 5 multiple choice questions? Let's test and see where you are right now, and how you're looking in terms of being prepared for that test. So there's some good software out there right now, good interventions where instructors can especially help those students who are at risk of not doing well by sort of, forcing them to adopt good study skills.
Great, thank you. Any other questions from members of the audience? We've got time, so I want to open it up and just give some time for people to ask questions. We've had a couple of good questions so far, and we do have time for just a few more. I was really interested, Dan Levine, about just what you were talking about this craving versus liking, and sort of the relationship. And it really, I was trying to think of different areas where you have a craving for something, but you don't necessarily either like what's going on, or you like it, but that craving takes place. It sort of applies to kind of, could apply to a number of different areas in life, right?
Yeah, and maybe even maybe even to some political choices people have. There's craving or obsession with certain types of misinformation that doesn't necessarily mean people like what they're hearing. So which areas were you thinking of?
I was thinking of a lot of them. I mean, I was thinking of gambling.
Yes,
people crave the
gambling.
the feeling. They may not necessarily like what's going on or like but they crave, just as one example. Yeah,
there's a lot of work done, and in fact, I talk about this in an undergraduate course I give most years on behavior and motivation. That behavioral addictions, it's not yet verified, but there seems to be some evidence that they activate the same kinds of dopamine systems in the brain that physical drug addictions do. So you could have behavioral addictions to shopping, to pornography, to gambling, as you mentioned, to overwork, a variety of others. Now, chocolate's another addiction, but that could be a physical substance. But there seems to be general belief that behavioral addictions are ultimately, physiologically, work the same way as drug addictions do. That the drug or the behavior, that the replenishment of the dopamine in the brain, which is involved in any kind of motivated action, the replenishment is dependent, becomes dependent on a particular activity. An obsessive compulsive behavior is probably closely tied to that too.
Right. We have another question in the chat. Could Dr. Robinson please recommend resources for further learning? Do you have, is there something that you could just off the top of your head recommend?
If you Google retrieval practice, one of my good friends, Pooja Agarwal, Agarwal, she's in the Boston area. She has put together a website for retrieval practice, and it has a number of free resources. And I'll try to find that and see if I can paste it in the live event Q&A, and that would be a good place to start. And you could also email me, and I'm happy to share any resources that I have. Daniel.robinson@uta.edu.
Here's another question. With trying to change a certain behavior, why or what brain area creates a smaller change more successful than forcing a big change? She says, I'm reading the book, The Kaizen Way.
What brain area would be most involved in successful changing behavior? Is that the question?
Yeah, when trying to change a certain behavior, what brain area creates a smaller change more successfully than forcing a bigger change?
I don't know if there is one brain area that stands out as most successful. And what we really need to do is study the effects on the brain of behavioral intervention. You know, that just because something takes place in the brain doesn't mean that you need to go into the brain to change it. Sometimes a behavioral intervention will work. Sometimes just a change in the environment will change behavior. Sometimes just people feeling there's a possibility of a different kind of action than they're performing. This is how psychotherapy works at its best. Give somebody an option for something that's an alternative to the kind of self-destructive behavior they're going on. So I don't think it really involves one brain area. I think all these different brain areas cooperate in it. You know, if there's anything that's sort of the, you know, controller, it's, if anything, I don't really think there's a controller, but this orbital and ventral medial part of the frontal lobes may be the closest we have to it, and the anterior cingulate cortex, because those tie the instinctive and emotional parts to the more calculating parts of the brain. Not sure that completely answers the question, but that's what comes to mind.
Well, that's great. Well, listen, I'd like to thank both of you very much for your participation today, for sharing your expertise and your knowledge, and to everyone who attended. I appreciate it. Here's contact information for our speakers. If you're interested in finding out more about their research, the emails are there. Also, the website for the psychology department for the College of Education. If you'd like to know more about the Center for Research on Teaching and Learning Excellence, if you've got questions about what we do, there's our email there. and also the website as well, uta.edu/CRTLE. And feel free to reach out to any of us if you've got further questions or would like more information.
I would add that our website in the Department of Psychology is undergoing some changes right now. So some previous links that I had to articles of mine and even to ordering books are not there right now, but I'm told they will be restored once certain changes are made at the College of Science level.
There's a lot of changes as we move to a new platform, I think university-wide. So
yeah,
that's good to know. I appreciate that. Our next Creative Escapes event will be Forensic Science, Fact, and Fiction. So we've got two speakers from the College of Liberal Arts. Dr. Roxanne Zaskavage deals a lot with from the Department of Criminology and Criminal Justice, looks a lot at forensic science, and so she'll be talking about fingerprinting, DNA technology, and the CSI effect. And then paired with her is Dr. Neil Matheson from the Department of English, and he's going to be looking at incriminating traces, forensic science, and detective fiction. So kind of really a fact and fiction type of presentation where Dr. Zaskavage is going to be looking at some of the use of DNA technology and in forensic science and the CSI effect, and then Dr. Matheson looking at how it's portrayed both in the past and currently in fiction work. So that's coming up August the 11th from 4 p.m. to 5 p.m. But again, I'd like to thank our presenters very much and thank you for attending, and we hope to see you at our next event.